This is an interesting problem called the Tower of Hanoi, where there are 3 rods and we have n number of discs placed in a particular order in one of the rods. Right, this largest is at the bottom and slowly it's smaller and smaller. So what is the objective of this problem? So it is to move the entire stack in the same order and place it to another stack in exactly the same way. Like here we are taking it to the third place. So like after the end of the puzzle, you should get a similar kind of configuration in the third rod, right? And this first rod will become empty. So like you cannot arbitrarily move like the disk to one rod to another. So you have to follow some rules. So like you can move only one disk at a time. So like you may not take this 2 disk and move some like together to another rod. So you have to move one disk at a time. And the second one is that so you can move only the topmost disk, right? So you can only, suppose this is the topmost disk here, so you can only move this to somewhere else, like, so you cannot like take this random disk from the middle and then move it, right? So you have to move the topmost disk. And the third one is that no disks may be placed on a top of the smaller disk, right? So let's see how you can solve this problem. Okay, so here, without the loss of generality, we can assume that these disks are present in the first rod, right? And we are planning to take it to the third rod. Okay, so this third rod is where we are planning to get our text to, right? So let's see how we can do and how we can like form a recurrence out of this thing. Okay, so we are trying to solve this using recursive relations, right? So you can see a crucial step in solving this may be thought of like this way. So you can somehow move this n-1 disks, right, to here. So here is exactly this stack of this n-1 disk. Okay, so it's not like you're taking the whole this bunch of n- disks here. So what we are assuming is that so if n disk can be moved from one place to another, there must be a way to first to like take the upper n-1 disk, because otherwise the bottom disk cannot be touched. Okay, so what we are assuming here is that so somehow we are able to manage this n-1 disk to, so suppose this middle rod, right? So in this middle rod we are like taking this whole system to, and then this third one is vacant, so that like this configuration is the largest disk that is at here, and this n-2 disks are here, and this one is empty. So like this, since this consists of moving this n-1 disk, so let's suppose take some variables. Let L be the total number of steps that may be required to solve this problem, and the similar thing is happening for this n-1 disk, right? So we are like taking a n-1 steps to move this upper branch of bunch of n-1 disks to this place, right? So it's already taking a n-1 steps. So let's see what additional steps it's taking. So so this is the first step what we are doing. In the second step what we are doing, so this large disk we can transfer it to the third rod, right? So it's like the third rod will get here and this will go there, and what you are left with this configuration, right? So the here n-1 disks are placed as usual, so what you've done in the first step. So it's taking an additional step of one step of doing this act, right? In the third stage, what we are doing, we are again taking this lot of n-1 disks and like moving in the top of the largest disk, right? So again we are doing the same thing. We are actually moving n-1 disks in order to another rod, right? So we will require another n minus 1 steps for this, because we are doing the same thing literally. So we are again taking this n minus 1 disks and moving to another rod, right? So it will again take n minus 1 steps. So after this, the largest will be at the bottom, and then slowly the other disks what are there. So if I draw a clear picture here, so in the final step, this nth largest disk will be here, and the above there will be this n minus 1 disk stacked in order. So the whole collection will be completed, right, after this number of steps. Okay, so what you have got here is that, so an is like 2an minus 1 plus 1. So this is the lesson what we are looking for here. Okay, so what we will do from this relation, this an is equal to an minus 1, what you can do, we can just like solve using a recurrence relation formula, right? So but this is a special case of the recurrence. So like, let's explore it for some time. So let's see if we could do it another way. So let's see. So if an is to a n minus 1 plus 1, then we can again like convert this a n minus 1 to a n minus 2. It will be 2 a n minus 2 plus 1, and again the last plus 1 is there, right? So it's becoming 2 square a n minus 1 plus 2 plus 1, right? Again, you can substitute this n minus 2 using terms of n minus 3. So 2a n minus 3 plus 1, this is becoming this again plus 2 plus 1 is remaining. So it's like 2 to the power a, 2 to the power 3 a n minus 3 plus 2 square plus 2 plus 1, right? So if you like go on and on, what we will see, it will be like this. So if it's 3, so let's take it as a n minus 1, it will be a. So like if 3 is there here, so this time is n minus 3, so this will be like n minus this n minus 1, right? And here it's starting from 2, so it will start from 2, so one term less than this n minus 1, that is n minus 2. Then second, after that it will be n minus 3 till 2 square plus 2 plus 1, right? So what we got finally is 2 to the power n minus 1 a1, right, plus 2 to the power n minus 2, so 2 to the power n minus 2, 2 to the power n minus 3, and till now this 2 square, 2 and 1, right? So now let us see what is a1. Say a1 is basically there is only one disk, and we are trying to move it in the third place, right? So what you can do, you can easily in one step you can move this here, right? So a1 is actually 1, right? So you put this value, it will be 2a n minus 1 plus 2 n minus 2 until this 2 square plus 2 plus 1. So you can see this is a GP series. So with there are like this number of terms. So this is the first term, this is the second term, this is the third term, and so on. This is the nth term, right? So the third term is 2 square, the fourth term will be 2 cube, so nth term will be 2 to the power n minus 1. So here the first term is 1, the common ratio is 2, and number of terms are n, right? So what will be this sum? So if you sum this GP, it will be a r means 2 to the power n minus 1 by this r minus 1. So this is a r to the power n minus 1 by r minus 1. So this is basically 2 to the power n minus 1. So you can see that this an is 2 to the power n minus 1. So this many number of steps are required to solve this problem, right? So like if you have 5 rods, it will need 2 to the power 5 minus 1, that is 31 number of steps, and it grows exponentially. So if there are 10 number, so it's like 1023 number of steps, right? So thank you, that was about the problem.